Hi friends, today I will tell you about electricity. Electricity means study related to charges. Electricity is classified into two types. One electrostatics. Electrostatics means the study related to stationary charges. While the other part of electricity is current electricity, that is the study related to moving charges. Now question comes, what is a charge? Charge is the property after attaining which a body begins to attract light particles. Now SI unit of charge is Coulomb and is defined as the amount of charge that passes through any section of a conductor when a current of 1 ampere is allowed to pass through it for 1 second. It means 1 coulomb will be equal to 1 ampere into 1 second. Hence, its dimensional formula will be A into T. A stands for ampere and T for time. Charge is of two types, one positive and another negative. And we know that the like charges repel each other while opposite charges attract each other. Now, how to produce charges on the bodies? To produce charges on the bodies, we will have to consider the composition of body. Every body is made up of atoms, and atoms have the central densest part called nucleus containing neutrons and protons. Neutrons are electrically neutral while protons are positively charged. Around the nucleus revolve electrons in various orbits. Number of electrons in any orbit can be given by 2n square. N is the number of orbit. Now, in an atom, number of electrons is always equal to number of protons. Also, negative charge of electron is equal to minus 1.6 into 10 to the power minus 19 coulomb, while positive charge of proton is also 1.6 into 10 to the power minus 19 coulomb. As the magnitudes of charges are equal, natures are opposite, number of electrons and number of protons in atoms are equal, hence atom is electrically neutral. Since atom is the building block of any material, so every material or every body in its normal state will be electrically neutral. Then how to create charges? To create charges on the bodies, we will have to create a difference in number of electrons and number of protons in that body. To create that difference, either we will have to migrate electrons from one body to another or protons from one body to another. But protons are bound within the nucleus by strongest forces of nature called nuclear forces that cannot be overcome under ordinary conditions. It means to overcome nuclear forces, conditions like that at Sun are required, which are impossible on Earth's surface under ordinary conditions. Hence, migration of protons from one body to another is not possible under ordinary conditions. Then the other possibility is to migrate electrons from one body to another, because electrons are bound to the nucleus by comparatively weak electric forces. Now, if a body loses electrons, then in that body number of protons will become more than the number of electrons, hence the body will gain positive charge, while the other body that will receive electrons will have more number of electrons than the number of protons, so that body will be negatively charged. Since electronic charge is the least possible charge, so the number of electrons transferred from one body to another will always be in integer. That is, charge on a body will always be an integral multiple of electronic charge. It is called condition of quantization of charge, and any quantity that cannot have all possible values is called quantized. Since charge cannot have all possible values, that will always be either plus minus E, plus minus 2E, plus minus 3E, like that. Hence, charge will be quantized. Also, the charge gained by one body will be positive, while the charge gained by another body will be negative. Also, the amount of these charges will be same. Hence, total charge before chargification was 0, and after chargification also it will remain 0. It means the charge is conserved. It is law of conservation of charge. Charge can neither be created nor be destroyed. It can only be transferred from one body to another. And total charge before chargification will remain same as the total charge after chargification. One of the ways of producing charges on the bodies is by rubbing the bodies against each other. When two bodies are rubbed against each other, then at the cost of energy supplied in rubbing the bodies, the electrons migrate from one body to another, making one body positively charged and another body negatively charged. If a glass rod is rubbed with silk, then electrons migrate from glass rod to silk, making glass rod positively charged while silk negatively charged. If ebonite rod, ebonite is a black colored wood called wood obtained from armwoods. If ebonite rod is rubbed with cat's skin, then electrons migrate from cat's skin to ebonite rod, making cat's skin positively charged while ebonite rod negatively charged. If amber is a resinous substance obtained from plants and it is commonly called lark, and if amber is rubbed with fur, then also electrons migrate from fur to amber, making a deficiency of electrons on fur. Hence, fur gets positively charged while an excess of electrons on amber, making amber negatively charged. When a plastic scale or comb is rubbed with dry hair, then electrons migrate from dry hair to plastic scale or comb, making dry hair positively charged while plastic scale or comb negatively charged. Similarly, when a rubber balloon is rubbed with woolen clothes, then electrons migrate from woolen clothes to rubber balloon, making deficiency of electrons on woolen clothes and hence making it positively charged, while an excess of electrons on rubber balloon, making the rubber balloon negatively charged. And it's our common experience that if after rubbing a rubber balloon with woolen cloth, we will leave it near the wall, then it will get stuck to the wall because of electric induction. The next thing is electrostatic induction. Electrostatic induction is the phenomenon of production of charges on a neutral body when it is brought closer to a charged body. Say a neutral body is kept over an insulating stand and a charged body, say glass rod rubbed with silk, is brought near it. If glass rod rubbed with silk we are taking, then it will be positively charged, and the positive charge on glass rod will attract electrons from the neutral body. So electrons will get collected at the end of neutral body closer to charged body, making this end negatively charged, while the farthest end of neutral body will become positively charged. These charges will be developed on the neutral body due to the presence of charged body near it. As soon as this charged body will be moved away from neutral body, these charges will disappear. These charges which are developed on neutral body are called induced charges, while charge on charged body is called inducing charge. Here Q, inducing charge, while Qi, induced charge. These induced and inducing charge remain associated with each other by this formula. Qi is equal to Q into 1 minus 1 upon K. Here K is called dielectric constant, or relative permittivity, or specific inductive capacity. Of material of neutral body. Next thing will be Coulomb's law. Coulomb's law gives an expression for the force between two charges. If two charges Q1 and Q2 are separated by a distance r, then by Coulomb, the force between these two charges will be directly proportional to the product of magnitudes of the charges and will be inversely proportional to the square of distance between them. If we will combine these two things, then F is equal to 1 over 4 pi epsilon naught K Q1 Q2 upon R square. Here K equal to epsilon R is equal to dielectric constant or relative permittivity of material of the medium between the two charges. Epsilon naught is equal to 8.85 into 10 to the power minus 12, and unit of epsilon naught Coulomb square upon Newton meter square is called electric permittivity of free space. It determines the electrification of free space when charge is placed in it, while dielectric constant determines how many times more a medium can be electrified by a given charge as compared to free space. That is, epsilon r or K is epsilon by epsilon naught, or you may say epsilon is equal to epsilon naught K. From here it is obvious that K or epsilon r determines how many times more a medium is electrified by a given charge as compared to the electrification of free space by the same charge. For air or vacuum, K is equal to epsilon naught upon epsilon naught, that is 1. So force between charges when placed in vacuum will be 1 over 4 pi epsilon naught Q1 Q2 upon R square. If we will substitute the value of epsilon naught here, then it will come out to be 9 into 10 to the power 9 Q1 Q2 upon R square. From 1 and 2, we find that 2 divided by 1 gives K. So K is equal to F naught upon F. That is, dielectric constant of a medium can be defined as the ratio of force between two charges placed at a certain separation in vacuum to the force between same two charges placed at same separation in medium. Now, if we want to find out the expression of Coulomb's law in vector form, then with these magnitudes we will have to add the direction. If we want to find out the force experienced by Q1 due to Q2, then we will have to consider the signs of Q1 and Q2. If say we are considering both are of same sign, then Q2 will repel Q1, so Q1 will experience a force by Q2 away from Q2. This will be the force on Q1 due to 2, F12. Similarly, F21 can be written as force on Q2 due to Q1. If these two charges will be of opposite nature, then the directions of these two forces will reverse. It means if charges will be of opposite nature, then Q1 will attract Q2 while Q2 will attract Q1. Now, in vector form, F12, that is force on Q1 due to Q2, is equal to magnitude already we are having 1 over 4 pi epsilon naught Q1 Q2 upon R square into direction. Direction of this force is from 2 to 1. It is directed from Q2 to Q1, so it will be given by unit vector R21. Unit vector is obtained by dividing the vector by its own magnitude. So it will be written as 1 over 4 pi epsilon naught Q1 Q2 upon R square into vector R21 upon R. This implies F12 is equal to 1 over 4 pi epsilon naught Q1 Q2 upon R cube into vector R21. Similarly, force on Q2 due to Q1 F21 is equal to 1 over 4 pi epsilon naught K Q1 Q2 upon R square into unit vector R12, because this force will be directed from Q1 to Q2. It can be written as 1 over 4 pi epsilon naught K Q1 Q2 upon R cube into vector R12. If we come to the characteristics of electric force, then electric force between two charges is central force, that is, it acts along the line joining the two charges. Also, it obeys inverse square law, that is, it is inversely proportional to square of distance between the two charges. Principle of superposition applies to all vectors. If two or more forces act simultaneously on a charge, then resultant of all those forces will be vector sum of the forces. It means if a charge Q is having charges Q1, Q2, Q3 and so on near it, then say Q2 is negative while all other charges are positive, then Q1 will repel Q, Q2 will attract Q, say these forces F1, F2 and Q3 will repel Q, say the forces F3 and so on. The other charges may also be taken into account. Then the net force on Q F is equal to F1 plus F2 plus F3 plus so on. And for finding this sum, we must be knowing addition of two or more vectors. Now, equilibrium of charges. Equilibrium means there is no change in state of the body even when a number of forces are applied on it. And equilibrium can be translational as well as rotational. For translational equilibrium, sum total of all the forces acting on the body should be 0, while for rotational equilibrium, sum total of all the torques or the turning effects on the body should be 0. And if body is having translational as well as rotational both the equilibrium, then the body is said to be in equilibrium. But here, while considering the equilibrium of charges, we will be requiring only translational equilibrium. Here, we will consider two different cases. When a charge is in equilibrium between two fixed charges, or the other case in which a charge is in equilibrium between two free charges. If we are considering the first case, equilibrium of a charge between two fixed charges, say the two fixed charges are Q1 and Q2, and we have to consider the equilibrium of another charge Q. Then, since these two charges are phased, so there is no need to consider the forces on these two charges. We will have to consider forces on charge Q only. If all three charges are of same nature, then Q1 will repel Q, while Q2 will repel Q in opposite direction. It means the forces on Q are in opposite directions. By varying the distance between the charges, we can make these two forces equal in magnitude, and in that situation Q will be in equilibrium. So it means a free charge can be in equilibrium between two fixed charges of same nature. And for that, F1 is equal to F2 implies 1 over 4 pi epsilon naught. If these distances are R1 and R2, then 1 over 4 pi epsilon naught Q1Q upon R1 square is equal to 1 over 4 pi epsilon naught Q2Q upon R2 square. This implies Q1 upon R1 square is equal to Q2 upon R2 square. If these are the fixed charges Q1 and Q2 and are of opposite nature, then if we will place a charge Q, whether positive or negative, it will experience the force. If it is positive, then it will experience both the forces towards negative charge, and if it is negative charge, it will experience both the forces towards positive charge. Hence, Q cannot remain in equilibrium. Similarly, we can consider the case when this charge Q is lying outside the fixed charges. If charge Q lies outside the fixed charges, these are the fixed charges, say both are of same nature, then if charge Q is also of same nature, then these two charges will exert forces in same direction. Hence, net force on Q can never be zero. So charge Q can never be in equilibrium. So it means outside two fixed charges along the same line, the charge of same nature can never be in equilibrium. In the same way, in other situations, you can also find whether the net force on the charge Q can be made zero or not. If the net force on the charge Q can be made zero, it will be in equilibrium, otherwise equilibrium will not be possible. Now we will consider the case of equilibrium of a charge between two free charges. Again, we can take various cases. Say these are the two free charges Q1 and Q2, and we have to consider the equilibrium of a third charge Q. If Q is also of same nature, then for Q, Q2 will exert a force towards Q1, Q1 will exert a force on Q towards Q2, so Q can be in equilibrium. But when we will come to the equilibrium of Q1 and Q2, then Q2 will experience a force due to Q away from Q. Similarly, Q1 also away from Q. It means the equilibrium of Q2 will not be possible. So it means if all the three charges are like charges, then equilibrium of a charge between two free charges will not be possible. But if the charge in the middle of these two charges is of opposite nature, then Q1 will attract Q towards itself, exerting force F1. Q2 will attract Q towards itself, exerting force F2. Similarly, Q1 will experience attraction due to minus Q. So this force is F1O, and force on Q1 due to Q2 is F12. Then these two forces being in opposite direction, equilibrium of Q1 is also possible. And for Q2, Q2 will experience a force due to Q1 away from Q1, F21, while force experienced by Q2 due to minus Q will be towards negative charge, F20. These two forces acting on the charges can be varied by varying the distances, such that the net force on each charge is 0, and wherever net force on each charge will become 0, the system will come to an equilibrium. If these distances are, say, R1 and R2, then for equilibrium of Q1, F12 means 1 over 4 pi epsilon naught Q1 Q2 upon R1 plus R2 whole square equal to F10 1 over 4 pi epsilon naught Q1Q upon R1 square implies Q2 upon R1 plus R2 whole square equal to Q upon R1 square. For equilibrium of Q, F1 is equal to F2 implies 1 over 4 pi epsilon naught Q1 upon R1 square is equal to 1 over 4 pi epsilon naught Q2 upon R2 square implies Q1 upon R1 square is equal to Q2 upon R2 square. From these two equations, you can obtain the desired result in a numerical. If you think this video is of any help for you, then please share it with your friends so that they may also be benefited by it.